Okay, so our plan for today, first is to, well, we're going to do a couple things. We're going to finish the in-class exercise relating to the while loops, and then we're going to learn about plotting. So plotting is kind of our next thing that we're going to learn in MATLAB. I'm going to do this in a little bit of kind of reversed order. So we're going to talk about plotting first, and then we'll go back and have some time to finish up the in-class exercise from last time, because some people finished all of them and some people didn't, so I don't want the people that finished them to be bored and waiting around for me to do something. So we're going to talk about plotting first, then we'll have time to work on the while loop in-class exercise, and then the next in-class exercise about plotting. And we'll have today, whatever we have left at the end of today, and almost all of class on Wednesday to work on, to get both of those in-class exercises done. So they're both, the while loop one and the plotting one won't be due until the end of class on Wednesday. So we've got a little bit of time for flexibility on that. And if you submitted something, was it Friday last week, you can always resubmit, update your assignment that you had. All right? Any questions before we get started? Okay, so as a reminder, for some upcoming dates that are coming up, we've got homework 5 that's due on Wednesday, and then quiz number 2, based on our vote that we took in class on Friday, is going to be moved and is now going to be on the 5th, which is 1 week from today. So today we're going to learn about plotting in MATLAB, and in order to do that, we're going to answer our question of the day today, which is, how do I create the shear force and bending moment plots for a beam? So we're going to create those two diagrams in MATLAB and be able to kind of understand how we can do different things with plotting using MATLAB. It's pretty easy and a nice skill to learn that you'll probably use in a lot of your other classes. Once you learn how to plot things, it makes it a lot easier to display and look at your results. So we're going to have a cantilever beam. That's what we're going to try to solve today. So we have a cantilever beam. It has a distributed load on it. The magnitude of that distributed load is 300 Newton meters, and our beam is 6 meters long. If we look at, oh, one more thing, we've got the diameter of the beam, we're going to call D. So if we were to figure out what the shear force and the bending moment of the beam are, we can use two equations. We can calculate our shear force in newtons as V is equal to 900 minus 25 d squared, and our bending moment is M is equal to negative 3600 plus 900 times D minus 25 over 3 d to the third. So now that we have these two equations for our shear force and our bending moment, and we've got the couple parameters defined, we want to be able to calculate the shear force and the bending moment at any distance along the beam. So we want to generate a bunch of distances for the whole length of the beam, and then to be able to calculate the shear force and the bending moment at all those points, and then create some plots so that we can actually look at what the trend is over the distance of the beam. So how are we going to do this? We can write, a MATLAB script or a MATLAB function, our choice, whatever we want to do. So what do you guys want to do? Script or function? Script. Everybody likes scripts. Why? Because they're easier, right? You don't have to follow that format and remember how to run them, and yeah. So scripts are usually everybody's favorite. Unfortunately, I make you write functions because it's good for you. The torture. So we'll write a script. And what do we put at the top of scripts? We got our header and that kind of stuff, but that's optional, right? But what do we have to put at the top of a script? Yeah, so we'll say we're going to calculate the shear force and bending moment of a beam. And then we could put inputs and outputs, but we'll skip that part for now. What's next?
Inputs. We can input the T.
Do we jump to inputs, or something else we should do first? Housekeeping, right? Why do we put our housekeeping tasks in a script? So clears out our workspace, gets rid of all the variables, and then CLC does what?
CLC clears
the command window, just what we see in the command window, but doesn't influence our diary file. So the diary file continues going even if we do a CLC. So CLC just clears out what's visible in the command window. So now we can get to input, right? So the only input, we have a couple different variables. We have the length of the beam, and then we have D, which is our distance along the beam, and we're going to want D to be a vector of some sort. So we could define it inside of our script, or we could get some sort of input from the user. If we were going to get input from the user to get D, how do we do that?
D equal input, and then drag the message for the user.
So D is equal to input, because we can use the input command in a script, but not in a function, right? So in the input command, we can say enter a vector of distances along the beam, something like that. And then we can define the variables that we have. We really only need, well, actually we don't really need any variables because our equation only has the D in it, so we're kind of good on variables. We don't even need to define L or the load that we applied, kind of incorporated that already into the equation. So we really don't have any variables to define here in this problem, so I'm going to take that out. So now that we've got D, what else do we need? We need to use our equations, right? And we want to calculate a shear force, and we want to calculate a bending moment for each one of our D values that we have in our vector. So what kind of things do we need to write to do that? I want to calculate shear force and bending moment for every D value that I have. Yep.
Can we put in a valuable section?
Well, we don't really, we could, but I already kind of substituted L in, so I don't really need it in this equation.
I think you need to define like any variable to be like flexible to calculate, any length of vector that the user put it.
Right. So D is going to be a vector, so we need our code to be able to handle a vector. It could be, or they could give us one value, or they could give us 1,000 values, right? And so in order to do that, in order to calculate V and M for a vector of D values, do we need something special like a loop, or can we just use the equation as it is?
I think we can use the
We can just use the equation, right?
Yeah.
And what will we have to make sure we're using in that equation though, if we've got a vector? Well, do we need a for loop would be the question. Not really. You could use a for loop if you wanted to. It'd be kind of overkill. Because MATLAB, remember, before we learned for loops, if D is a vector, we can just plug that into this equation, right? We just have to make sure we use what? Like if we're going to square a vector, we need the dots, right? So we got to remember to use our dots appropriately. But we don't need a for loop. We could use a for loop if we wanted to, but it's kind of overkill. We don't really need that. MATLAB takes care of vector type calculations. As long as they're in an equation like that, we don't really need a for loop. So we can just write out our equations. So our equations for shear force and bending moment. So we can say V is equal to 900 minus 25 times D squared. And if D is a vector, where do I need dots? Do I need a dot for my minus sign here? before the power, right, here. So to raise a vector to a power, you have to have a dot. Do I need a dot here for 25 times d squared? Vector times a scalar? No dot, right? So the only dot I need is for raising d to the power of 2. So now we have our bending moment equation. So we can say m is equal to negative 3600 plus 900 times d minus 25 divided by 3 times d to the third power. Where do we need dots?
For the minus 25 dot divided by.
We need a dot here?
No.
25 divided by 3 is scalar divided by scalar, right?
The D was also
The d's out to the right, so 25 divided by 3 is a scalar, multiplied by a vector, so that's scalar times a vector, no dot, right? Where do we need dots? Before the power. Anywhere else? No, so no more dots. So this relatively simple equation, 1 dot per equation. Anything else? Do I need parentheses anywhere or anything like that?
I think parentheses for 25 divided by 3.
I could put them there if that made me feel better. You know, if that makes me feel better that this 25 divided by 3 is happening before it gets multiplied by d to the third, but it's not necessary because MATLAB's reading from left to right, and it's going to do the division 25 divided by 3 before it multiplies by the vector d. So it's not necessary, but you could put them in there. Wouldn't hurt anything. So now we've calculated, or we've input d, and then we've calculated v, and we've calculated m. So if we input d with a vector of 50 values, how many values do we expect to be in v and m? 50, right? If we got 50 as our input, we're going to get 50 as our output. So when we go to create our plots of our bending moment and our shear force diagram, one of the rules when we plot things in MATLAB is that we have to have the same number of elements, the same number of things that we plot on the x-axis and we plot on the y-axis of our plot. That's the rule. Otherwise, MATLAB's going to get angry and yell at us. So that's one of the things you have to think about when you're going to plot things. So you have to set up your code so that you're going to have data that has the same number of points on your x-axis and the same number of points on your y-axis. So that's one of the things you have to remember. So plotting in MATLAB is kind of intuitive. Once you figure out the commands, they make a lot of sense to you. So we're going to plot our shear force and bending moment. And there's a couple different ways that you can do plotting in MATLAB. The simplest way is just 2D line plots. And if you go to the help documentation and you search for the word plot, MATLAB will take you to the plot command, which it'll tell you is just a 2D line plot. So you're going to get stuff you can put on an x-axis, stuff you can put on a y-axis, same kind of plots that you probably make all the time in Excel, but you can do them in MATLAB. There are lots and lots of different types of plots in MATLAB. We're only going to talk about 2D line plots in this class. There are, you can see over here on the left, there's plot 3, which is a 3D plot. There are also all sorts of different other types of plots. So this is just the line plot section. You can also create pie charts and bar graphs. You can create contour plots. You can create vector field plots in MATLAB. So you can do all sorts of things in MATLAB. Very powerful in terms of plotting, kind of visualizing data. We're just going to get kind of a very brief intro to that in this class. Fortunately, a lot of the plotting commands kind of work the same way. So if you figured out plot, you can probably kind of figure out some of the other ones. They're very, very similar in the way that they work. So if you ever need to find information about other types of plots in MATLAB, use the help, use Google, same kind of rules we've applied all throughout class. So if we want to do a 2D line plot for our shear force and bending moment diagrams, we've got just a couple things that we need to learn. First off, whenever we are plotting something in MATLAB, it's going to create a new window that's going to open up, that's going to have our plot in it, and this is called a figure window. And we tell MATLAB that we want this figure window by putting in the command figure. And so that just, opens a figure window. It's not 100% necessary if you only have one plot that you're trying to plot, but I always just like to do it to be in the habit of having it there. And we'll see in a minute, it'll come up and be handy. So we're going to open our figure window, and then we get to use the plot command. So we tell MATLAB what we want to plot. And there are a bunch of different ways that we can use the plot command. The most simple way is to tell MATLAB what information we want on the x-axis and what information we want on the y-axis. So what we're going to do in this case is we're going to plot our variable d, so our distance along the beam, on the x-axis, and then we're going to plot our shear force v on the y-axis. So if you do d comma v, closure parentheses, MATLAB's going to create that nice simple plot, d on the x-axis, v on the y-axis. Now if we want to plot also our bending moment on the same plot, we're going to need to tell MATLAB, again, another plot command. So we'll have plot d comma m. So we'll have d on our x-axis, and then now the m values on our y-axis. However, MATLAB needs to know that we want to plot both of those two things on the same figure in the same window. And so we have to add one extra command. We have to say, hold on, and that tells MATLAB, hey, keep that first line that I plotted on the window, then I'm going to add another line, and I can add as many lines as I want now on top of that same figure window. You only have to have one hold on command after the very first plot, and then you can have a whole bunch of plots after that. You don't need to add extra hold-ons. But if you don't put that hold on there, then you're only going to get one curve on your plot that's going to come up. So that's the very basic keys of plotting. So let's go ahead and save this and run it and see what happens. So we're going to save this. And we'll call this beam plots. And then because I got a script, I can hit the magic run button. And I'm going to enter a vector of distances. So I'll use my linspace command, and we're going to generate them between 0 and 6 meters, which is the length of our beam. And then I'm just going to generate the default 100 points. I'm not going to tell MATLAB how many points to generate. And if we've had success, we should get a nice figure window that pops up, and we have two lines on the same plot. How'd we do? Okay. So what's one of the nice things about this is that we have these two lines, but we don't really know what they are. Yes, sir? So that's a new feature of newer versions of MATLAB, is that it will automatically permute through the colors and change them for you. The old versions of MATLAB don't do that by default. They'll just plot blue lines, so you probably have two blue lines. Which is perfectly fine for the most part. On homework and things in this class, I kind of tell you either what to do or how to do it. So I don't for the most part let people use just the default colors that pop up. So you won't be at any disadvantage if your MATLAB doesn't do that automatically for you. And we'll talk in just a second about how to change those. So we've got two lines. One, if they're both blue, or if one's blue and one's red, we don't know which one's which really very easily. And then what if I wanted these to look a little bit differently, things like that. We can do all of that in MATLAB. We can also label our axes, put a title on, do all sorts of things. So let's go ahead and close this figure, and then we'll talk a little bit about figure formatting. So if I want to, for example, change my line to have a different color, or to be a dashed line rather than a solid line, do all sorts of things. I can go back to my help documentation in MATLAB and look at some of the things that MATLAB tells me I have as options when I'm plotting things. So in addition to just specifying what the x data and the y data are, we can specify what are called line specs in MATLAB. And the line specs tell us how to change the colors and the types of lines that we have. You can also change what are called markers of lines. So if we look down here at this example on the MATLAB help documentation, you can create all sorts of different lines with circles and squares and stars and all sorts of different things. These are all called line specs in MATLAB. And if you just search the documentation for line spec, LINESPEC, MATLAB will take you to this series of tables that are really helpful for you to be able to find and use. I don't have all of these things memorized. I don't expect any of you to have them all memorized, but know where to find them. And if I ask you to create a line, a dashed line with circle markers and that's magenta or something like that, you can come into MATLAB, come into the help documentation and kind of look up and see how to do that. So for example, if we wanted to create and tell MATLAB that we want a dashed line, so we've got 2 dashes here to create a dashed line. We want to use circle markers, that's an O there, and then I want the line to be green, for example. I can tell MATLAB all of these things right after that plot command. So I can go into my plot command for my shear force diagram, put another comma, and then inside the single quotes I can put all of my different line specifications one right after the other. They don't have to be in any particular order. I can just throw them all in here one right after the other and MATLAB figures it out. So that would be a dashed line with circle markers and a green curve. And so if I save this, run it one more time, enter in my linspace command, you'll see that now my shear force plot has changed and it now follows the specifications that I've given it. So if you want to specify what the type of line or anything like that, you can go ahead and do that in the line spec for a particular plot.
Excuse me, Brooks. I have like a problem with my M value.
Okay.
It's giving like an error or something like that. I don't know why.
Do you want to have, can you look at it while I keep talking? So in addition to changing the line specs, we can also, like I said, add axes labels, titles, all sorts of things to our plot. So if we want to add a title, the command for that is just title, and then inside single quotes, we can put the name of the title, so we could call this, beam plot, something like that. We could also add labels to our axes, so we can say X label is distance, and our Y label is force or moment, since we have both plotted here. So we can add all those labels. And then we can also add a legend. And we give MATLAB the legend entries or the legend labels, whatever we want to call them. Shear force and bending moment inside single quotes. We have to separate each legend by a comma, and the order that we give them to, the order that we give that to MATLAB, so we said shear force first, then bending moment, that depends on the order of the plot commands that we had. So our first plot command was to shear force, so our first legend label should be shear force. Our second plot command was for the bending moment, so our second label should be bending moment. So if we go ahead and save this and we run it one more time, you can see that now we have a plot and we have a legend up there in the top right, we got a title, we've got axes labels. So you can do all sorts of things. There's lots of more commands that you can use to be able to kind of customize your plots. These are the basic ones that we're going to use and learn in this class. I will say a couple words of warning. So when you're in this plot window, there is this nice insert drop-down menu, and you can insert an axes label, you can insert a legend, you can insert a title. it is kind of the lazy way of doing that because you're not writing the MATLAB code. And the second thing is that if you insert these within the figure window like this, MATLAB doesn't save that. So the next time that you go to run this code, you're going to have to go through and insert your axes labels and insert your title and do all of that again, which is really annoying. So you might as well just write the code, put it in there, and modify the plot so that every time you run the code, you always get the same output. You don't have to worry about going in and remembering to change it. And I will say that if you do modify your plot without putting the code in your MATLAB code that you turn in for like your homework, for example, you won't get credit for that. So make sure you do whatever modifications you do to your plot inside of your MATLAB code. There are a couple things that are kind of nice about this plot window in addition to that fancy insert thing. If you wanted to say zoom in on the plot, you've got some nice zoom buttons. You can either just click on the plot and it'll zoom in on that location, or you can draw, like click and drag and draw a square and MATLAB will zoom in on that point. You can also zoom out with the other button. One of the really nice things about plots is this data cursor tool. So if you click on this little data cursor, it's kind of like a plus sign with a little yellow box up to the top right, and you click on one of your lines that you have, MATLAB tells you what the x and y coordinates are at that particular point. So for this point, our x values are our distances, so we have a distance of 2.12, and our y value for that plot is our bending moment, our m value, and so that's negative 1770. So it tells you exactly what the coordinates are of that particular point, and if you right or left arrow or up and down arrow, you can go back and forth between all the different points and visualize what exactly MATLAB has plotted at those particular points. So the data cursor is really helpful, especially when you get to your homework and you want to check your answer with mine. You can kind of click on the data cursor, check and see if that matches with the solution that I've given you. Any questions about that so far? So with this one, we plotted shear force and we plotted bending moment on the same figure, which is kind of weird because we've got forces in newtons and we've got moments in newton meters, so it doesn't really seem logical to be able to plot those on top of each other. So what if we wanted to have two different plots? We could do that. So what I'm going to do is I'm just going to copy and paste this code and put it down here and just modify it a little bit to get, I'll put in a comment here, to have two figure windows. So we have our first figure command, we have our first plot command, those can stay the same. Instead of having a hold on here, I'm just going to add another figure command, and that's going to open up a second figure window that'll just have my plot for my moment diagram on it. So now if I run again, enter in my beam distance, I now have three figures because I left the original one there. So I have the first figure with both lines on it. I have my second figure with just the curve for the shear force on it, and then I have my third curve, or my third figure window with my bending moment diagram on it. So you'll see that MATLAB gave me some warnings, and what do these warnings say? So it's saying that I have extra legend entries, and why is that? Because I left my title and my X label and my Y label down here underneath the second figure. It doesn't transfer those, it doesn't put them on the first figure window. You have to tell MATLAB where to put those. So if I wanted them also on my first figure window, I have to put them up here before I have my second figure, before I kind of open up the second window and start working on that one. And then what do I want to do? I only have one curve, so I should only have one thing inside of my legend command. So the first one is our shear force, and the second one is only our bending moment. So if we only have one curve, MATLAB only expects one legend entry. So now if I hit run, I've got my three windows, three figures, and the last two are appropriately labeled with the right legend that I have on there. One more quick thing about plots. So if I wanted to say, rather than plotting them in two separate figure windows, if I wanted to have two plots within the same figure window, this is what MATLAB calls subplots. So I'm going to have kind of two plots all in one window that are right next to each other. I can do that as well. So how would we do that? We just have to kind of modify our code from before. So I'm going to copy the two figure window part of the code, paste it down here at the bottom, and change my comment to say two subplots in one figure window. So I still need a figure window to tell MATLAB that I want to open up that figure window. But before I do my plot command, I now need an extra command to tell MATLAB that I'm going to have what are called subplots. And so what that looks like is in MATLAB, I create my big figure window, and then I can create kind of mini figures inside of the bigger figure window. And I can have as many rows and as many columns of subplots as I want. So for example, this one has 2 rows and 3 columns. I could have 18 rows and 1 column. I could set up that subplot window however I want to. You have to tell MATLAB how to do that. And so in the subplot command, you tell MATLAB you want to create subplots, and then you tell MATLAB 3 numbers. The first number is the number of rows that you want. So in this case, we only have 2 things. So our subplot window would look like this. So we're going to do shear force on the top, bending moment on the bottom. So we'll have 2 rows of subplots. So we say 2. We have 1 column of subplots. So we'd say 1. And then we tell MATLAB which one of those subplots that we want to work on at this particular moment. And they kind of follow a particular order. They're going to start in the top left corner. They're going to go across the first row. Then they're going to go to the next row, down. So because we only have 1 subplot on our first row, we have 1 here. Then MATLAB comes down here and says 2. If we looked over here at this one, they'd be labeled, numbered 1, 2, 3, 4, 5, 6. So MATLAB goes across the first row, then goes down to the next one, and that's kind of the order of the subplot numbers. So in this case, for our 2 rows of subplot, 1 column of subplot, our first one goes on subplot number 1. Then we have our plot command, our title, our axis labels, all the things that we want to do on that particular subplot. And then we go down to our second subplot, and instead of having a figure here, we're going to replace that with another subplot command to tell MATLAB now we want to move down to the second subplot and plot our bending moment down there. Every time we use the subplot, we always have the same first 2 numbers. So we always tell MATLAB the total number of rows of subplots, the total number of columns of subplots, and then the only thing that should change is the subplot number. So in this case, the second one, because it's the one on the bottom. And if we run this now, our last, or our 4th figure window is going to have both of our subplots kind of in the same figure window that we have. All right. So that's kind of the basics of plotting. All the commands, I think, make logical sense. If you want to plot something, you use the plot command. If you want to put a title, you put a title. The hardest thing is figuring out the line specs, but you know, the line color and the style and all that kind of stuff, but you have the table to kind of help you do that. All right? So that's all I have to say about plots, unless anybody has any questions. Anything? Okay. So what we're going to do now is, if you have time, you have the rest of class today to finish up your in-class exercise regarding the while loops. I also will pass out the next in-class exercise that has to do with the plotting. The first problem on this one is to replicate a plot, so I'll put the plot up on the screen for you guys to see. And then the second one on the back is similar to a problem we've had before with the voltage of the battery thing, and you have to create a plot showing the output of that. So if you want to get started on that today, you can. But like I said, we'll have until the end of class next time to finish both of these. And if you're bored, you can work on your homework or whatever.
Excuse me.
Yep.